It has always been a challenge to perform mechanical thermal simulation on the designs created in an electromagnetic tool. The traditional processes have forced designers to waste a lot of time by passing the electromagnetic analysis results over to thermal engineers and wait for their response. We want to change all that by empowering electrical designers with quick thermal insight. Here is an example of an HFSS design. We aim to determine the mechanical heat profile of this package. This package is mounted on a board, and we have input and output transmission lines here. Embedded in this package would be an RF power amplifier with bond wires on the input, output, and ground plane. The signal coming in from the input will be amplified by the chip to the output as we would expect. At this stage, a designer may also need to quickly see the thermal performance of this electromagnetic design. This can be easily achieved using the new mechanical thermal solution in Ansys Electronics Desktop. A user can quickly import electromagnetic designs from HFSS, Maxwell, or Q3D into mechanical for thermal analysis. First, a mechanical design type must be added in the same GUI. Copy and paste the model from the HFSS design into the mechanical design type. Assign the EM excitation loss to this model by selecting this option and link it to the HFSS source project. This shows that we are transferring the losses from the volumes of the dielectric and surface of the metal pieces and bringing them in as heat loads for mechanical. For mechanical thermal analysis, we also need to assign the convection boundaries to this model to understand how the heat transfers from its surface to the air surrounding it. Next, set up the thermal analysis and import the mesh generated from HFSS, and we are done. Run the simulation by clicking on this option. Plot the temperature fields. Now you can see exactly what's heating up in this model and its complete temperature profile. Be it for any electromagnetic designs in HFSS, Maxwell, or Q3D, Mechanical Thermal Solution in Electronics Desktop provides an FEA thermal solution, allowing design engineers the ability to get quick thermal insights into a design without any complicated setup and analysis in the same environment. Try this new workflow on your design today.
A new era is upon us. Ubiquitous connectivity, low latency, and faster data rates are enabling transformational products. Products that will rely on advanced FinFET processes and 2.5D and 3D packaging technologies to meet the insatiable need for more compute power and performance. So how do you build transformational products? From early design analysis to final sign-off, Ansys empowers you with big data analytics, elastic compute scalability, and multi-physics simulations, all for one purpose: to achieve silicon-to-system success. Ansys solutions break down your design margins and siloed methodologies with multi-physics simulations and actionable analytics. Rapidly iterate designs and accelerate time to results using advanced custom analytics, powerful visualizations, and machine learning. Gain key insights from your data early in the process, identifying weaknesses and prioritizing fixes. Ansys provides comprehensive workflows for chip-aware system and system-aware chip sign-off, all to achieve early power efficiency, electronic system reliability, immunity against electromagnetic crosstalk effects, and regulatory compliance for mission-critical applications. Today's advanced 7nm SoCs are challenged with increased variation effects as they push for lower power. This variability has become the new enemy at advanced technology nodes. The solution? Ansys lets you simultaneously address voltage variability and timing issues together. Solve your engineering challenges across the full spectrum of chip, package, and system design. Leverage best-in-class simulation. Accelerate time to market. Guarantee product performance. Achieve first-time silicon-to-system success with Ansys.
Complexity of products knows no limits today. These products are a complex combination of many elements working together. For example, the model shown here consists of an IC on a package, a PCB with a connector, a cable with two antennas, one on top for GPS and a camera, and the other one on the bottom for remote control, and 4 blades as part of a drone. Such products are an example of a true system. The solutions that exist today neglect several electromagnetic effects, since it's possible to simulate such full systems together. Traditionally, engineers have been compelled to simulate each of these components, for example, the package, the PCB, connectors, cables, and antennas separately. But now, the new groundbreaking HFSS mesh fusion technology will make simulating full systems together possible without compromising on accuracy. You can easily select all the components in a system upon which you want to apply mesh fusion technology and choose a meshing method of your choice for any components in your system, and quickly simulate the whole system together. Generating the mesh for this complex system is easy. To view the mesh of the drone structure, simply click on the option under Field Overlay. You can also plot the fields of the complete system in a similar way and visualize the fields under Field Overlay. Generating S parameters of this large EM system is the same as with an HFSS simulation. For example, you can simply go to Network Data Explorer under Analysis option to view various S parameter plots. Quickly select and extract the S parameters you need into a touchstone file or any other output file format, and use this file for your downstream circuit and system simulation needs. Simulation is the key to breakthrough innovation, and HFSS mesh fusion technology provides the capacity to simulate such large complex systems in one go with the gold standard accuracy and reliability of HFSS. Assemble your design with 3D components, and mesh fusion will simulate your entire system together without compromising any accuracy. Be it a system with IC packaging, PCBs, and cables, or a co-site problem with multiple antennas in a single aircraft antenna, or even a touchscreen panel TV in an EMI chamber, mesh fusion technology has the sophistication and capacity to solve any complex electromagnetic system. Try this new technology and stretch the simulation horizons on your design today. Simulate your complete system with the confidence of Ansys HFSS.
In today's ultra-competitive markets, across all industries, our customers are increasing their reliance on smart and connected devices used in applications such as IoT, smart cities, automotive, next-generation medical applications, and more. At the forefront of this race, forward-looking companies are differentiating themselves through the access to advanced and customized computing capabilities. From AI hyperscalers to neuromorphic engines, from quantum computing to photonics, from spatial mode to orthogonal frequency division transmissions, the name of the game is bespoke silicon. Designing and manufacturing these made-to-order, optimized silicon on advanced semiconductor nodes implies intricate and challenging trade-offs between complexity, performance, and environmental goals, while adhering to schedule and budget. And as more of these devices become smart with chips of their own, they also transmit and receive with thousands of other devices across huge distances. Tremendous advancements in intelligent connectivity are happening, requiring significantly more complex antenna and data processing systems. The massive amount of data processed by these radio links imposes to the underlying chips and hardware designs a high level of robustness and reliability. Therefore, not only electrical performance needs to be considered, but also optical, thermal, and mechanical reliability considerations are a major factor in longevity and capability. The role of Ansys, the leader in engineering simulation, is to address and solve all these engineering challenges, enabling bespoke silicon and intelligent connectivity for the high-tech industry. Now, for bespoke silicon, Ansys helps designers create 3D integrated circuits, which are used for power, signal, thermal, and mechanical sign-off. We help measure the IR impact on design and performance, and we can be used for systems that are designed for security at the hardware level and for the future quantum computing systems. For semiconductor and electronics manufacturing challenges, Ansys helps with blank wafer production, semiconductor manufacturing, assembly and packaging, and printed circuit board reliability, just to name a few. And for intelligent connectivity, our software helps maintain the integrity for signal, power, thermal, optical, and mechanical designs, antenna system designs and integration, chip package systems, and RF, EMI, EMC cable analysis. Ansys solutions analyze and validate systems as small as subsections of the die to as large as global satellite communication systems. Intelligent connectivity is changing the fabric of our society, and Ansys simulation is used in everything from the microchip level to missions into space. These are just a few of the examples of how Ansys simulation is contributing to our partners' tremendous acceleration of the high-tech industry.